Welcome guys to conditional statements and deductive reasonings. This is basically day one of proofs. We're going to be learning the different if-then statements, all the different kinds of logic stuff, or at least the introduction into them. This section is really important to know well, because just like points, lines, and planes, the rest of the chapter, the rest of the year is going to build on this section. All right. My best advice as we go into this section is if ever you get confused, say the thing out loud. Oftentimes it's easier to hear logic when you say it out loud than it is in your head. That being said, let's get started. So conditional statements, they're also called if-then statements, and they are formed in this kind of P then Q situation down here. All right, this arrow reads as then. So the way you would read this symbol here is if P, then Q. P is your hypothesis. Q is your conclusion. All right. Now we're going to be using P and Q as a way to see where the hypothesis and the conclusion move around. But the number one way to know this, to know what's the hypothesis and what's the conclusion, is the hypothesis is always behind the if. And the conclusion is always behind the then. Okay, I mean, a conditional is an if-then statement. So almost always it'll be in this if-then format. So if ever you want to know where your hypothesis is, look for the if, and it's right afterwards. And same thing with the conclusion. Now, different examples of if-then statements would be like this. So say your hypothesis, and the hypothesis in this instance is just a starting phrase. Okay, it's a fact. And then you draw a conclusion based on the fact. So my hypothesis, an animal is a robin. Okay, my conclusion then is the animal is a bird. So then if I was going to rewrite this as an if-then statement, it would give me this sentence down here. If an animal is a robin, then the animal is a bird. Okay, here is P, then Q. All right, take a moment. The video is going to pause. Label this bottom sentence down here. If you are born in Houston, then you are a Texan. Label the hypothesis and the conclusion using P, an arrow, and Q. Go. All right, this is your hypothesis right here. If you are born in Houston, then you are a Texan. And here we go. Now, this statement in this example, we took our hypothesis and our conclusion. They were nice, they were neat, they were already pre-labeled. Oftentimes, a very common type of question that you'll get is, here's a statement, rewrite it as a conditional. So you could almost title this slide, Rewriting as conditionals. Okay. The first thing to do whenever you are trying to rewrite a statement as a conditional is to find your hypothesis and your conclusion. But Ms. Stockton, you may say, we don't have an if or a then. How do we know? Well, I answer. Remember, the hypothesis is just the fact you start with. So when you're looking at your statement, midpoints create two congruent segments. What is the fact you're starting with? In this case, it's just midpoints. Midpoints exist, and they then create two congruent segments. So when you go to write your if-then statement, you just put in the pieces. If it is a midpoint, then it has two congruent segments, and you just put it in like that. The number one thing to remember when you're writing conditional statements is not to imply your own information. And what I mean by that is, if you were writing this one, don't be saying, if it is a midpoint that creates two congruent segments, then it has bisected the segment. Okay? You inserted the word bisect there. or I inserted the word bisect there. But bisect is nowhere in our original statement, which means it's not the conditional statement we were looking for. Okay? Whatever you do, do not add information to your original statement. Only use the words that are in the original statement. Now you can add little filler words here and there or grammar things to make it make sense, but do not go adding different concepts. Now, when we're rewriting conditional statements or rewriting things as conditional statements, there are many different ways that it can work. All of these mean the exact same thing. So this first one is kind of our tried and true standard. Majority of the time we'll be writing it like that. The second one implies, you won't see it often, but again, it's kind of logical. This bottom one we'll get into a little bit later. This is actually called a biconditional. All right. But it's this last one that I want to focus on. In all of these top three, the hypothesis comes first and then the conclusion. All right, it doesn't matter if the wording in between changes. Hypothesis, then conclusion. In this last one, the conclusion comes first. This is okay. Whenever you have these kinds of statements, always pay attention to where the if is. Because remember, the hypothesis is always going to be behind the if. So even if your statement looks a little weird in that there isn't an if up front, read the sentence and look and see if the if is in the back. Because this means the exact same thing. All the right information is still there. It's all in the same groupings. It just got rearranged for grammar's sake. So the math truth hasn't gone away. This question or this style of writing is very common on tests and quizzes. So make sure you know and are familiar with this kind of a setup. Now, I kind of said it while I was going over this answer. The truth of the math statement. It's an awkward way to word it. But with all of these different ways to write conditional statements, it becomes an important thing of which one is true. So the truth value of a conditional is simply whether something is true or not. Because I can make anything an if-then statement, and that doesn't mean it's true. I could say if it's wet, then it's water, which wouldn't be true because there's a whole bunch of other liquids. So counterexamples are a big deal here. And they will be a big deal throughout the rest of the year, so get to know counterexamples. A counterexample is when the hypothesis is true, but the conclusion is false. And this is the most important thing about counterexamples. The hypothesis is true, the conclusion is false. And I'll explain that in a moment. The other big thing about counterexamples is they must be specific. And it must be specific, because a counterexample is the only way to show that a conditional statement is false. It's a lot like having to defend your statements and defend your arguments. So take these examples down here. If you can divide an integer by another integer, the result is also an integer. So if you haven't forgotten, or for those of you who have forgotten your number sense, an integer is your counting numbers. So 1, 2, 3, 4, 5. There aren't any decimals in here. So no decimals, no fractions. So it's saying if you divide an integer by another one, the result is also an integer. Well, here's an example of this. So we have 4 divided by 2. That gives us 2. This is an example of the statement. But if I wanted a counterexample, I could say 1 divided by 2. That gives us 0.5. 0.5 is not an integer, therefore this statement is false. Okay, let's go to the next one. If you live in Texas, then you're a Cowboys fan. Okay, a counterexample of this would be if you live in Texas, then you are a Yankees fan. Okay, or you're a Texans fan. Okay. Now this last one, if it has 4 sides, then it's a triangle. Remember that in order for it to be a counterexample, the hypothesis has to be true and the conclusion is false. So a good counterexample for this bottom one would be if it has 4 sides, then it is a square. Okay? But what you could not do, I'll write this in red so you know you can't do it. What you can't do is if it has 4 sides, then it's a triangle. False, Miss Stockton, because a triangle is not how you spell triangle. Have 3 sides. The statement is false. This is not a counterexample, okay? Because you've made the conclusion true. That's not how this works. You have to make the hypothesis true by fixing the conclusion, not the other way around. All right, you also couldn't give a vague example. So in this second one, if you are in Texas, then you are a Cowboys fan. What you couldn't say is, if you live in Texas, then you don't have to be a Cowboys fan. All right, that's not specific enough. Think of it like your English essays. You can't just say something is true, you have to back it up with text. Okay, same thing with counterexamples. You can't just say the statement is false, you have to have a specific example. All right. Now, going from that, we're going to take a pause on that one and move to other conditional statements. There are actually 4 kinds of conditional statements. You have the original one, the conditional. All right, this is the one we normally do. It's the one we've been talking about, P then Q. But then you have these other ones, converse, inverse, and contrapositives. Now, we will spend the majority of our time this semester going over converse and conditional statements. All right. We will eventually get to inverse and contrapositives, but that won't be till later. We're going to go over it now so that you know what it is and what's going on, so that it's not a big surprise later on. The video is going to pause here. Make sure you have all of the symbols written down and how you read it. So basically these 2 columns right here. Now the last thing I want to go over on this slide is this squiggly line symbol right here. Okay, now that I've zoomed in, you can't see the squiggle. But it is that. So here, I'll rewrite this. What this squiggle is, and I really don't have a better way of saying that, this is not. So the way you would read this statement right here is, if not P, then not Q. Just like it says over here. But if ever you want to contradict something, you're going to put that little squiggle there. It's not the hypothesis. It's not the conclusion. Now, with these related conditionals, you're going to start with the conditional statement. If P, then Q. So first we have the hypothesis. So if you're born in Texas, and then you have your conclusion. Now for the converse, you're just going to flip them. So your conclusion is actually now your hypothesis, and your hypothesis is now your conclusion. Which means when you read this, if you are a Texan, then you are born in Houston. All you did was flip the 2 statements. Now with the inverse, the P and the Q stay in the same place. But this time, you're negating both of them. So you're going to use your little the squiggle symbol. So if you are not born in Houston, so not P, then not Q. If you are not born in Houston, then you are not a Texan. And then last but not least is contrapositive. You're going to flip the P and the Q and then negate both of them. So you have not Q up front and then not P in the back. And remember, these P's and these Q's are based off of the conditional statement. So when in doubt, always go back to the conditional statement. All right. So this is just how to write these statements. I'm sure as you've been going through, you've been seeing a few problems just in the truth value of these statements. What I want you to do, the video is going to pause. Go through and write true or false by each of these statements. If it's true, then leave it alone. If it's false, provide a counterexample that proves it. All right. Here's the next slide. So the conditional and the contrapositive were true, but the converse and the inverse were false. Your counterexamples could have been something along the lines of, if you are a Texan, then you were born in Dallas, or any other city in Texas. And the same thing also works for the inverse. So if you're not born in Houston, then you're not a Texan. Well, that's clearly false. Dallas could work as a counterexample for here, because if you were born in Dallas, then you're not born in Houston, but you're still in Texas. So it proves the hypothesis to be true and the conclusion to be false. Now, something to notice here about these truth values. The conditional statement and the contrapositive statements will always be logically equivalent. So if the conditional is true, the contrapositive is true. If the conditional is false, the contrapositive is false. Likewise, the converse and the inverse are logically equivalent. So if one is false, the converse is false, the inverse is false, and same thing for if they're true. Now in this example, the conditional is true and the converse is false. And this is actually true of a lot of statements. But there is the statement where the conditional and the converse are both true. These are called biconditionals. All right? And when you write it, and it's written right here, you have this double arrow. So the way you would say this statement is P if and only if Q. So the hypothesis is true if and only if the conclusion is true. A common example of this is a lot of your definitions, like the definition for a right angle. An angle is a right angle if and only if it measures 90. Well, your conditional for this, if you were to rewrite this as a normal conditional statement, you have this one right here. If the angle is right, then it measures 90. That's true. Then if you were to take this sentence or this conditional and rewrite it as a converse, you would get this down here. If the angle measures 90, then it's a right angle. Well, that's also true. Okay? So here you have a situation where both the conditional and the converse are both true. In this case, what you have is your biconditional statement. Now, we won't run into a lot of biconditional statements. For the most part, it's going to be mainly your definitions. But it is important that you know how to break a biconditional into the two conditional and converse statements, and that you can go backwards, so that you can take a conditional and converse statement and turn it into a biconditional. Well, this is the end of the PowerPoint. Please make sure that you know all the vocab from this section. Like, look at it, read it. This is just one of those sections that it takes a while to wrap your brain around. But once you get your brain wrapped around it, it makes the rest of the chapter and the rest of the unit semester just so much easier. So please pay attention and know all of these vocab words. If you have not gotten yourself some flashcards, now is the time to get that started. All right, I'll see you next time, guys.